This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
And welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, a continuation of Zero Trust Data with SafeLiShare and its CEO, Shamim Naqvi. Explain a little bit then what SafeLiShare will do for me. What kind of specific use cases you guys are talking about? Because it sounds like, hey, I can safely share my data. I don't lose control of my data when I share it. Is that really
Right.
what you guys, that's really what you're targeting, correct?
Right. The crux of the problem is, can I allow you to access in some measure, access in quotation marks?
Right.
Can I allow you to access my data? Or to put it in other words, can we construct a workload that I can control its output and its execution in certain well-defined ways? So let me give you an example. You have a model, and the model can process patient records, MRIs or bone fracture X-rays, etc. Provide a very useful service in doing a whole bunch of analysis and taking some of the workload off the hands of the physicians in this particular case. But you want to protect the privacy of the patients and all the other tests that the test results, etc., that are a part of the record of the patient. So that is the problem. How do you allow your model to run on patient data and make sure that you may be a malicious party and you are exfiltrating the patient data off on the side as you are performing this service? Can we make sure of that? Can we, or perhaps we provide you the patient data, but then we are trusting you with the patient data, and you say, I'll run my model on this patient data and give you the result. And trust me, I will keep the patient data safe. So that is one model, right?
Right.
So I am trusting you with the patient data.
Yeah, but that kind of flies in the face of zero trust, where I trust no one and I monitor and control continuously, right?
Yeah. So let's first put some more definition around this notion of zero trust. I spoke to John Kinderwag, who is one of the people who came up with this notion of zero trust, and he calls it a strategy. So how do you implement a zero trust strategy? In this particular case, as you have said, when I give you the data, that's not a zero trust strategy.
No, that's not.
Right. So I say to you, Darren, you give me the model. You send the model to me.
That's not a zero trust strategy either, because I just gave my model to you.
You just gave your model, and the IP of the model is now at my mercy.
Yeah.
Right? So how can we make either of these two situations work out, that the IP of the model is protected and the privacy of the patient data is protected, and yet the computation happens?
I know the answer to this.
Yes.
I do. It's called confidential computing.
Yeah. So
right?
There are these recent developments that hardware manufacturers have now provided, and all the major public cloud providers have these machines available now with these chipsets that essentially provide what are referred to as secure enclaves or trusted execution environments, etc. And one way to do this problem, which we are discussing, is to use these machines to execute the workload. So whether you send the model, you don't send the model to where the data is. You give the model to a secure enclave, and the data is provided in some fashion to the secure enclave, and the computation happens inside the secure enclave. And the secure enclave attests to its own integrity, saying nobody had access to it, to the contents of the secure enclave. So everything is encrypted outside the secure enclave. You hang on to your keys, and everything comes into the secure enclave. And when it comes into the enclave, it is decrypted inside the enclave.
But only inside the enclave.
But only inside the enclave.
Yeah. Yeah, this is really cool because it's almost like I set up a security box
Exactly.
and gave 2 keys to 2 separate people.
Right.
Said, put your stuff in there.
Right.
And then in the end, the results will come out.
Exactly. And you can, and the results will come out encrypted.
Encrypted, yeah, yeah. So even the results are protected.
Even the results are protected. And you can say it should go to X. And X can now use a private key that only X has access to. And you can then follow these kinds of computations with define a notion of a chain of custody to say who had access to unencrypted information. And ultimately, you will know the bad guy if there is a bad guy in such a computational chain of custody.
Now, there's been some issues with confidential computing in the past. It's been primarily because it's difficult to use, difficult to set up. Is that something that your company is tackling? Is making it easier to consume, making it easier to set up these enclaves and put things in the enclaves that 2 parties can, agree to? Is that where you're focusing on? Because
that is one of the
technology is hard.
That is one of the focus points. All new technology is hard, right? It starts out hard. It starts out hard. Back to our Bell Labs days, we used to say, the best technology hides in the walls. You never have to.
You never have to see it. Yeah, that's exactly right.
Right. You never had to teach people how to dial a phone call.
You know what, Shamim? I've tried. I have teenagers. They don't know how to pick up and use a normal phone. It's the funniest thing in the world to watch them try. Yeah. Especially a dial. The click dial. They look at that and go, I don't even know what that means. It's hilarious.
Well, it started out that way. In the very, very old days, people used to pick up the phone and say, get me the tailor.
Yeah, that's right. And guess what? On the smartphones we have today, it's just like that. I just talk to it and say, get me so-and-so, and it happens.
You don't dial a number anymore. You talk to Siri.
Yeah, that's right. Yeah, you talk to Siri or, Bixby or one of the other ones that are out there. So this is really interesting. New technology,
hard to use, and you require a lot of experience in setting up these black boxes and things like that, and moving your computation in and out and things like this. But there is another difficulty that is not so well known, which is that the world is full of services being defined and have been defined for the last 10, 15, 20 years or so. And we are all used to using these services. I'm talking about online services, of course.
Yeah.
Not all these services run inside of secure enclaves.
No, they don't.
So now I have a problem.
The number that run inside are very small. Right?
Very small, right. So now I have a problem. I want to use all these interesting services. So, for example, you are at AWS, and they have this very nice model called Anthropic. I want to use it, but it doesn't run in a secure enclave. I want to use AWS Lake Formation. It doesn't run inside a secure enclave. What do I do? So there is a weaker notion of confidentiality that SafeLiShare is working on, which is you don't have to have everything run inside a secure enclave, but you start to trust. It's a notion of trust. You say, do you trust AWS Anthropic? Can I have a computation in which there is a trusted AWS service? And that notion of trust, the notion of trust in this black box and the secure enclave part of the computation is based on hardware providing the certification. the hardware providing the attestation. But in the other case, in the case of AWS, and I'm using AWS as an example, of course,
Right.
you're saying, I buy the argument that AWS makes, that it is providing a trusted service and nobody is looking at it, and AWS has gone through the hoops in making it a secure, trusted, private service. And let me use that from so my computation comes out of the black box, uses Anthropic or whatever service, and the rest of the computation still happens inside the black box. And I call that a witnessed execution.
Ooh,
There is a
witness
witness.
execution.
Yeah.
Interesting.
So it's a weaker notion of trust, in the sense that I am trusting some guarantees being provided by the service provider in this case.
But I'm not completely in the open.
But I'm not completely in the open.
Gotcha. A witness. I like that concept. I think it's fascinating because we've been dealing with some issues similar to that in the Department of Defense and some things I've been working on, where they want data from non-verified, non-attested data sources. Right. And we called those untrusted, but everything else is trusted. So you have to deal with that concept.
Too sharp a distinction. It's too sharp a word to use to say everything should be trusted or everything else is untrusted.
Right. Yeah. It's too much. Yeah, I agree.
There's something it's too binary a word like that. If you think like that, there is something. You say, look, I trust the data being provided by Darren. And if you let me compute with it, at least I'll know if there's a problem, I can go to Darren.
Yeah, that's right. Yeah.
Right. So SafeLiShare is interested in doing things along that line to scale to get around some of the limitations of confidential computing that are in place today. And I'll give you an example of a limitation, which is striking. A large number of workloads that need confidential computing are machine learning workloads.
Right.
Because machine learning, nobody has enough data for their machine learning tasks. And no one has all the models that they want to run on their data. So there is this great need in machine learning circles to share data and models. In fact, all the customers that I am talking to and hope to sell my SafeLiShare stuff to, the large majority of them come from the machine learning world. Okay. So now, what's the issue? The issue is that the use of GPUs, the connection to the GPU is not secure.
Nope, it's not.
So now I have to turn around to my customers and say, yeah, I can help you with the privacy part of your machine learning workload, but you have to stop using GPUs. And
GPUs, yeah.
And
I'm okay if they stop using GPUs and just use CPUs. That's fine for Intel, right?
Right. That's fine for Intel. But, well, actually, there's a finer point. You would like them to use Intel's GPUs.
Yes, I want them to use Intel's GPUs. So let's just put confidential computing on Intel's GPUs. Oh, guess what? That's going to happen.
Right.
So how do you solve this problem? Right?
You solve this problem by saying and you solve the problem by saying that the GPU service, if I'm using from company N, where N could stand for the name of the company.
N stands for NVIDIA. We know that.
Right. So I didn't want to use that name on you listening to me. It's a witnessed execution. You are trusting the fact that NVIDIA knows and has done things to protect the data when it is computing on the GPU, when the weights and the biases are being calculated on the GPU.
This is a hybrid. It's a hybrid confidential computing approach.
It's not a hybrid confidential computing approach. It's a less limiting confidential computing approach, because I think there will always be services that somehow are difficult to run inside of secure enclaves. How about a notebook? I want to use my notebook. I want to tweak my model. I want to run it in an enclave. I want to get it back. I want to share it with you and make some changes, collaborative computing, etc. It may be very hard to do these kinds of
things. It may be, yeah.
Very, very strict model of confidential computing. Once I've deployed it, once I've deployed the model, then I can see that I can constrain the usage of it, right? But if in the training phase, it's very hard for me to believe that this very strict notion of confidential computing will pass. I think we have to ameliorate this very strict notion of confidential computing with something like a witness.
Like the witness computing concept. I really like the idea, and I think it's something that we most definitely should watch in the future. Because you're right, not everything can be black and white. Now, if everything was greenfield and I'm doing everything from scratch, that's a different story. I could probably figure out a way to do that, but not everything is like that in the real world.
No, it never is. The greenfield, I mean, the world is built in stages.
Yes.
Right. And there's always a stage that came before your stage.
Yes. Oh, for some reason.
I'm reading from a data lake. Data lakes lock the queries. So I'm reading from the data lake from a secure enclave, and I think I have confidential computing going on. No, because the query that's executing in the data lake is being logged by the data lake operator. So
yeah, exactly.
The data lake operator knows what query I'm running.
Which you don't. Yeah, if you want real confidential computing, you don't have.
If you want real confidential computing, so the notion of confidential computing is fascinating, but to make it practical, you have to have some ways of incorporating controlled variations, some weaker notions into that. So that is, I think that is an interesting area of research. How do you allow that to happen and still have trust in the system?
So that's the key, is what level of trust. So I think you're right. There's going to be a continuum of trust.
Yeah, exactly.
Right?
And that is the notion I want to push, which is there are different notions of confidentiality or different notions of trust. If you take the audit log being generated by a secure enclave, by a trusted execution environment, that is a highly secure proof that you can present and say, here, my execution can be trusted. But now here is another one. My execution can be trusted modulo Anthropic.
Yeah, I see where you're going with this.
Right? Everything,
that's pretty cool.
Everything checks out, but I used Anthropic in this process. Nothing else is wrong. Nothing else happened except for this one use of Anthropic.
Right. So, and there I could actually limit what data is going to Anthropic in that case. Right. Exactly. So my whole workload could be witnessed.
Yeah.
Right. And different aspects are under full control, while this one part is not. So I kind of like that.
Let me give you a use case. Let me
hear a use case.
I take my customer provides a model into the secure enclave. I send the model to be further retrained using Anthropic. Let's just continue using this example.
Okay.
So I get a retrained model back from Anthropic, witnessed by Anthropic, and now I have a retrained model which I run in a secure enclave. So note what I did. I took your model, I added to its learnability by using a witnessed Anthropic execution, which has a weaker notion of confidentiality or trust associated with it. But it is a guarantee given by the Anthropic designers that they have taken certain measures to protect.
Right. I trust it to some degree.
So it went out of the secure enclave, retweaked the model, I bring it back into the secure enclave, and now I take a data set from you and run that in a confidential compute manner on this new data set and provide you the results.
Yeah. That
That's a very
makes sense.
powerful model.
Yeah, to me, this makes more sense than what has been paralyzing people in the past, which says everything in my whole workflow has to be in a confidential computing or a secure enclave. Otherwise, I'm not secure.
Yeah.
Or it's all or nothing. So I really like this notion of
It's like
witness.
trying to clean up the city streets. There are going to be some dirty streets somewhere.
Yeah, there's going to be some spots that are dirty. Yeah. No, I agree. Hey, Shamim, this has been wonderful. We're out of time. If people want to learn more about these concepts, witness computing, where do they find out more information?
SafeLiShare.com.
SafeLiShare.com. All right. So they can go to your website. Yeah, I'm sure you guys have white papers on the subject.
Yeah.
And
we have
your technology. It's available today for purchase. How does that all work?
Yeah, we have a product. We call it the SafeLiShare Clean Room product. We have a set of very easy to use APIs. We just give us a call, give us a visit at our website. You'll see all sorts of interesting ways in which you can use SafeLiShare.
That's awesome. And it runs on-prem, in the cloud?
It does not run on-prem. It runs in the cloud today.
Oh, it runs in the cloud. So it's a SaaS type solution then?
It's a platform as a service. It's a
platform,
PaaS.
a PaaS. Okay. Very good. Shamim, it's been wonderful. This has been enlightening for me. Hopefully for our audience too, as we start delving more into zero trust. And today, obviously, zero trust around data. I love the concept. And I see a huge future in this in the near future.
Yeah. Again, zero trust is a strategy, and a part of the strategy is to say, I can use secure enclaves, and I can use secure enclaves in conjunction with witness computing, and still call it a zero trust because that's
and
my
still
strategy.
call it zero trust. Yeah. No, I love the concept. I really do. Thanks again, Shamim.
Thank you, Darren, for having me, and wonderful to chat with you. Cheers.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.